Hello, my pre-algebra honors friends, both in Mr. Stanton's room and my room. Welcome to the first of our flipped classroom, if you will. This is the notes being taken at home, and then we do some activities um, to solidify this topic when we get to class. So we're going to do this with section 1.2. You should have your notes in front of you and a pencil. Please feel free to stop this video at any time and listen to it again, or stop it, do the work I ask you to work, and then resume listening to it. I've written some of the vocab ahead of time. We are going to talk about exponents in this particular section, and I've given you an example over here, 19 to the exponent of 3. In this particular example, the base is 19, the exponent is 3. I think that's pretty obvious, but the whole thing is called power because the definition of a power is the result of repeated multiplication of the same factor. So that means 19 is repeated. It's the same factor 3 times. So the whole thing is called power. The base is 19 and the exponent is 3. So that's pretty straightforward. You've had this before. Let's talk about our friend 0. What is 0? What is the value of 0 raised to any non-zero whole number exponent? For instance, 0 to the 3rd power, 0 to the 2nd power, 0 to the 15th power. All of these have 0 as a repeated factor. 0 times 0 times 0, 3 times, 0 repeated twice, 0 repeated 15 times, and I think the answer is pretty clear that the product is 0, because 0 times any number, certainly 0 times himself, is always 0. There is something kind of funky, though, that we'll get to at a little bit later section, but I wanted to point out to you, what if 0 is the exponent? Not the base, but the exponent. So 4 to the 0 power. What about 13 to the 0 power? I want to leave that answer hanging with you. Think about what you would think that any non-zero base to the 0 power would be. Might not be what you think. All right, so let's look what a couple of these evaluates come out to be. Remember, the word evaluate has the root word value. So we need to know what is the value of this expression, x raised to the exponent of 4, when x is 1/2 or 0.5. So we would plug it in if our problem was x to the 4th, when x is equal to 0.5, as if we, not 0.05, sorry, 0.5. If we plug in for x, we make a shell. We put our exponent up here, 4, and then I'm going to go plop 0.5 or 1/2 in there. And if we stretched it out to make it expanded, it would look like this, 0.5, repeated as a factor 4 times. And I'm going to leave that answer to you as well because I'm kind of lazy right now and I don't want to do all that work right here. Actually, in class, I'm going to show you a really fast, fun way to do it on the graphing calculator. But for now, if you wouldn't mind just doing that by hand, that'll give you a little practice with decimals. Let's give that a try. Let's take the next one. This is a pretty simple example. This is all stretched out in standard form, stretched out. If we want to use an exponent to write it, we would say, well, 19 is the factor and it's repeated 3 times. Remember, mathematicians are inherently lazy. We like to write things accurately and certainly correctly, but as fast as possible. 19 to the 3rd power is faster than writing 19 times 19 times 19. And certainly if 19 were being repeated 17 times, I would not want to have to stretch out 17 19s. Kind of a different variation on the theme. Now I'm asking you to come up with the exponent. 2 repeated how many times gives you 8. So in other words, I need 2 as a factor some amount of times to give you a product of 8. And it's 3. So n is equal to 3. Why don't you figure out the next one for me? How many times do I have to repeat 4 as a factor to get up to 1024? So you guys can fill that in as you go. Here are some here's some algebraic expressions that we want to write using exponents. Again, x plus 2 is the factor. He's inside the parentheses. We'll leave him inside the parentheses and we'll just put an exponent on it, and that's a much easier way to write x plus 2 repeated as a factor 3 times. And here we've got 3 terms in this expression, but writing it like that is a little bit faster. These next problems are just some plug and chug kind of problems. I'm asking you to use the fact that x is 6, m is 4, and p is 3, and please evaluate these. So that means I want you to substitute for the variable the value that I give you, and I want your work nice and neat, organized down the page. Let me do the first one for you. So it would look like this. X is 6. This is your first step, and that's the only thing you do in the first step. And then we do a second step. We add 6 and 4. Before we do the exponent, we do the parentheses. 6 and 4 is 10 squared, and our answer is 100. So this is what your work needs to look like. Nice and neat, down the page, copied neatly from the book, and showing me every single step along the way. I'll let you finish up these 3 remaining ones, and we'll talk about those, go over those answers in class, and I'll move on here to the next page. So I want you to think up a synonym for the word formula. This isn't in your book necessarily. We talk about formulas a lot. Formula, probably when you say the word formula, you think of science or math as subjects. What would be another word that you might use for formula? I'm just wondering. And then we'll see if we can come up with a good definition for it. Maybe we'll brainstorm a little bit in class. These are the formulas that we're going to start right out of the block expecting you to know. These are important. You've learned them over and over again, and you need to have these at your command. This is the way I want them written. The area of a square, A, equals side squared. Area of a rectangle. Let's draw a square, actually, also. I like to draw pictures in math when I can. I'm going to draw this little guy, and I'm going to put these little hatch marks in here because that tells me that these sides are all the same length, which is, of course, what makes a square, among other things. And maybe we'll put a right angle here, too. More proper picture. The perimeter of a square, we're going around the sides. Remember the word rim. We're going around the rim, adding all the sides as we go. Perimeter is equal to side plus side plus side plus side, but that's 4 of those, 4 sides. We use the letter, the variable s, when we're dealing with a square because all of our sides are the same length. We don't really have a length and a width. We basically just have a side. Rectangle, let's draw one of him. Cute little guy. There he is. These sides are the same length. We'll put 1 little hatch mark and 2 over here. And we can put a right angle in his little corner as well. His area. Now we're going to use 2 variables because his length and his width are different numbers, are different measures. So we need to distinguish between the length and the width. And similar for the perimeter, we're going to go around and we're going to add all the sides together, a length and a width and a length and a width, but we can shorten that, lazy mathematicians, 2 lengths plus 2 widths. Last formula, which is one that we're using in this particular section, is volume, and volume specifically of a cube. What is volume? I want you to come up with a synonym for volume and have it ready for class. Formula for volume of a cube. Volume equals all 3 measurements, length, width, and height. But again, because they're all the same length, we just call it side cubed. The length, the width, and the height. If it were just of a rectangular solid, then you'd put length times width times height. All right, last page. So before I started this video, I drew my planter, which has my flowers in it. I'd ask you to do the same. This planter, let's see if I can see what it says here. I put that guy down there. So the florist has this cube-shaped planter, and we're asked to find the volume of the soil. I guess we're assuming that the soil goes all the way up to the top. That would be something that would have been helpful had the problem told us. Find the volume of the soil the guy needs to fill up the planter. So fill means, I guess, to the top. So when you're working these problems in the book, the first thing I want to see is the formula. This is the first thing you write. No substitutions yet, just the formula. Now make your shell. What are you going to substitute? You're going to substitute something in for the S. And now you're going to go and you're going to say, well, I'm going to put 16 in for the S. Now you would be finished, except 16 cubed, we need to simplify that. We need to actually get the answer to this problem. So I am wanting to know what 16 times 16 times 16 really is. Well, I know my squares pretty well. 16 times 16 is 256 times 16, and I'm going to let you finish that arithmetic up on your own. And we are going to say cubic centimeters because we add the unit, and it's cubic units because we have 3 dimensions to the volume. Okay, let's look at one more little idea here. The product, and I've got 6, I believe, 2, 4, 6 2's, can be written like this. I can group the first 3 2's times the second 3 2's. And then actually, I can write this, instead of 2 times 2 times 2, I can write it as 8. And I can write this as 8. And if I've got 8 as the repeated factor twice, I can write it as 8 squared. So that's one way to write 6 2's, 8 squared. Can you think of 2 other ways to write this same product, these 6 2's, as a power with an exponent? 2 other ways. 1, 2. And that's for you to do and to bring to class. Okay, we're done with the notes. Let's see if I can go find my little recorder. Where is it? Come on, recorder. Okay, this has been a 13-minute video. I try to keep them under 15 minutes. Sometimes I have to talk fast, but I got her done. So hopefully, if you need to watch it again, you can do that. Otherwise, I'll expect that you'll come in with your notes filled out. We'll talk a little bit about it, and we'll move on to an activity. Thanks for listening, you guys. Bye.